So we'll continue the topic. Yesterday we discussed about the properties of the matter, solid, liquid and gas, evaporation and boiling difference, as well as the Brownian motion. Today we'll discuss the gas laws, or the behavior of the gas in terms of, gas laws explain the relation between pressure, volume and temperature of a gas. So when we work out a relation between the pressure, the volume and the temperature, we discuss all these factors in a gas law. So as we know, for a gas, the particles are moving randomly. If these are the gas particles, these particles are moving randomly, means there's no specific direction. And how we define the term volume of a gas? The term volume of a gas means, the meaning of a volume, it is space occupied by the gas particles. So volume of the gas refers to the space occupied by gas molecules. And for a gas, normally the volume of the gas is same as the volume of the container, the space which is available for the particles. The second factor, the second thing is the pressure of the gas. The pressure of a gas refers to, it is force acting on unit area when gas molecules collide with walls of the container. So when the gas molecules collide with the walls of the container, these gas molecules exert force, and that force on a specific area refers to pressure. And why there is a force exerted by the gas molecule? So what is the reason? Because as we know, the gas molecules are moving randomly. Like example, this is a container. It is filled with a particle, a gas molecule. The mass of the gas molecule is m. And this particle is moving towards right with velocity v. But as this hits the or strike the wall, it bounce back, this particle rebound. The term rebound means bounce back. So this particle bounce back with the same speed, because the gas molecule does not change the speed when they hit the wall. So if velocity, as we know, velocity is a vector quantity. So if here the velocity is plus v, because the direction changes, the velocity, the magnitude does not change, but the direction change. That's why there is a change in velocity. And when the velocity change, the momentum also changes. Why? Because when it was moving towards the wall, the momentum is mv. When it bounce back or rebound, the momentum is minus mv. So why there is a force or a pressure by gas molecule? What is the reason for that? Because when gas molecules hit the wall of container, it changes its momentum which cause force on the wall result in or create pressure. So basically what happened as the gas molecule, they changes the momentum. Whenever there is a change in momentum, there is always a force. So gas molecule will apply force. And when there is a force on a specific area, so force divided by area, what we will have? We will have a pressure. This is how the gas molecules are exerting pressure on the walls. And if the pressure of the gas increase, what is the meaning? When we say so if there's an increase in pressure or if a pressure of gas increase, it means more molecules will hit the wall of container. The molecule does not lose energy when they hit. We call this type of collision as an elastic collision. There are two types of collisions. Some particles lose energy when they collide. We call inelastic. But for gas molecules, their collisions are perfectly elastic. Perfectly elastic means they don't lose any energy or their kinetic energy does not change. That's why their speed remain same. Means if it was moving with a speed of 20 meter per second, the magnitude of the speed will remain same 20. But velocity change, if one is positive, the other one is negative. This is assumption. This is just an assumption that perfect elastic collisions are there. In reality, the collisions here, they lose some of their energy. But assumption is that their collisions are perfectly elastic, so it does not lose any energy. So the speed does not change. Is it clear the concept? What is the volume of the gas? Volume of a gas means space occupied by the gas molecule. And what is the pressure of the gas? It is a force acting on unit area when gas molecules collide with the walls of container. And why the gas molecule exert pressure? Because it changes the momentum which create a force on a unit area. Result is pressure. And if the pressure of the gas increase, it means there will be more molecules hit the wall of container. Any doubt in this point till now? Take the screenshot. So I will move on to next part, which is temperature of the gas. The temperature of the gas the temperature of a gas, it is average kinetic energy of molecules. When we take the average of the kinetic energy of the gas molecule, what we call that? We call that as temperature. And as you studied in journal physics block 1, that kinetic energy is half mv square or 0.5 mv square. The mass of the gas molecule is constant. So what does it mean? It means if higher kinetic energy, the particle will move faster. So at high temperature, molecules have higher kinetic energy. So they will move at higher speed. And at low temperature, if we decrease the temperature, molecules have lower kinetic energy. So they will so the temperature affects the speed of at which the molecules are moving. So example, you have two containers. Container A and B are filled with identical gas, means same type of particles, same number of particles as well, same mass. Container A is at 30 degrees centigrade and container B is at 50 degrees centigrade. In which container the molecules are moving faster? So container B, the molecules are moving faster because higher temperature means higher kinetic energy. So the molecules will move at a higher speed. So here the molecules will move with a slow speed and the molecule will move at high speed. So changing the temperature changes the speed at which the particles are moving. So the three parameters which we will discuss now in the gas laws, we will discuss how relation between pressure, volume, and temperature. So volume is a space occupied by the gas molecule. Pressure is the number of the molecules which hit the wall of the container. And temperature refers to speed at which the particles are moving. Take the screenshot of this. The first law which we will discuss is known as the Boyle's law. So gas laws, there are three gas laws. One is called a Boyle's law. Second one is known as the Charles law. It is named after the physicist who explained the behavior. And the third one is, it's not given by any physicist. It's just a general idea developed by the two laws. That's called a pressure law. For Boyle's law, you have to learn in detail. For Charles' law, it is just an understanding, only the idea, the concept is important. Equation, you will not learn any equation for, there is equation for Charles' law as well, but you will not learn. Same thing for pressure law, there is an equation for pressure law as well. That also you will not learn. And these are the laws for gases. So first one is a Boyle's law. And what are these laws? These laws explain the relation between the Pascal law is actually not for, it's not a gas law because the Pascal law is for pressure on the liquid, pressure exerted by the liquid. But here we are discussing laws which relate gas. So these laws explain relation between pressure volume, and temperature of the gas. The Boyle's law you will learn in detail. The other law, only the introduction and the main theory will be there, but not the equation. So first, what is the Boyle's law? The Boyle's law states at constant temperature for fixed mass of a gas, pressure or volume of gas is inversely proportional to pressure applied. So this is a statement. What it states: at a constant temperature for a fixed mass of a gas, volume is inversely proportional to pressure. What does it mean? Example, you have a container. This is a container. And when your container is having a movable lid, we call that as a piston. So this is a piston. Piston here refers to movable lid. I can change the position. And these are the gas molecules or gas particles. For a fixed mass means like the number of the particles are same. And at constant temperature, example, it can be any temperature. Example, this temperature was 30. If I use the same container and I compress or push the piston, so this was original position of the piston. Now I push the piston. I'm pushing the piston down. So I change the position of the piston. So as we change the position of the piston, the number of the particle is same because we mentioned at a fixed mass and at a constant temperature. Also temperature, we are maintaining a temperature. We are not changing this. So this is the same piston, but this is the starting position at the beginning. And this one, when we push the piston, this is at the end. This is a new position of the piston. Now, which container or which container at the beginning or at the end having a greater volume of the gas? Greater volume, which condition we have a greater volume? In the beginning or at the end? At the start, we have a greater volume, higher volume. And at the end, we have small volume. Which container you think is a higher pressure? At first, we have which container is having a higher pressure or which. So at the end, we'll have high pressure. Why at the end we'll have high pressure? Because the molecules are closer. So as the molecules are closer, they will hit the wall often. But here, because the molecules have greater space between them, so less often they will collide with the wall of the container. So you can see here, if we have a greater volume, the pressure is less. If we have a small volume, the pressure is more. And that is the Boyle's law. It is stated that volume of a gas is inversely proportional to pressure. Means if we increase the volume, the pressure will decrease. If we decrease the volume, the pressure exerted by the gas will increase. Is it clear, the concept of Boyle's law? So Boyle's law states if you have two containers which are filled with the same amount of a gas and at a same temperature, temperature of the gas should also be same. So it states if we increase the pressure or if we reduce the volume, the pressure exerted by the gas will increase or a gas molecule would hit the wall often. You can take a simple example. Example, you have a balloon which is filled with air and say there are 5 air particles inside. Now I'm compressing the balloon. I try to compress the balloon. So when I try to compress the balloon, I try to reduce the size. So what happened? The size will increase, the size will decrease. As the size decreases, the molecules come closer to each other and they will hit the wall, they will hit the surface, inner wall of the balloon much harder. So which one you think will have high pressure? The first or the second? A or B? So the second one, it will exert a higher pressure. So the second one more likely, because you can take an example. That's why if you have a balloon and you try to compress the balloon might explode. Why it might explode? Because as you try to compress the balloon, the volume decreases. So gas molecule are hitting the wall often and it might explode or might higher pressure from the inside can explode this balloon. So how we can relate how the temperature is maintained here, because what happened when you are pushing the piston, so you are supplying energy, but how you can maintain, you can have a surrounding. If a temperature start to increase, so surrounding will absorb energy from the container. If a temperature start to decrease, surrounding will provide energy. So you try to maintain. This is the ideal case. These are known as the ideal gas laws, like it is working on ideal condition. In practical, what happened? The balloon will explode here because the number of the molecule are same. But what happened when you try to fill up the balloon? That's another example. When you try to fill up the balloon and you're continuously adding the molecules inside, the number of the molecules are more, so pressure increases and then the balloon explodes. But in this example, I mentioned we have a fixed mass or we have fixed number of the particles. So if we have fixed number of the particles, the one which is having a smaller volume will have a higher pressure, so the balloon might explode. But what you're saying if we try to inflate a balloon, you are adding an air to it. So when you are adding air means you are increasing the number of the particles. So number of particle increase, more collision, higher pressure. In that case, the balloon will explode. But this example is when you are keeping the air constant and you are reducing a size of a balloon. So as a balloon size you try to reduce at certain volume, the pressure will be too high, so the balloon might explode. Is it clear? This Boyle's law. This is about the theory that it states when you increase the pressure. This is about the theory which state. So whenever two quantities are inversely proportional, what we use the term, this mathematical relation. This is a mathematical representation that when two quantities are inversely proportional, we say P is inversely proportional to V or V is inversely proportional to P. And whenever two quantities are inversely proportional, the product is always constant. This is a way to identify if two quantities are inversely proportional. How I can identify? Whenever I will multiply them, I will always get a constant answer. So this is a way to identify that two quantities are inversely proportional from the values. So example, we have pressure and volume. Pressure is 100, volume is 2. Pressure is 50, pressure is 10, and pressure is 5. This is 40. Now, this is a table example which shows a relation pressure and the volume. How I can identify whether they are inversely proportional? Whenever two quantities are inversely proportional, their product is always constant. So when I multiply them, what I will get? I will get a constant answer. So 100 multiplied by 2, 200. 50 multiplied by 4, 200. 10 multiplied by 20, also 200. 5 multiplied by 40, that's also 200. So you can see here, whenever two quantities are inversely proportional, I'm decreasing the pressure. So as I decrease the pressure, the volume is increasing, but their product is constant. Whenever the product of the two quantities is constant, if one is increasing, other is decreasing, what we call this relation? We call this relation as inversely proportional relation. So Boyle's law states, when you increase the pressure, the volume decrease, or when you decrease the pressure, the volume increase, and the product will always be a constant value. Is it clear till now? Take the screenshot. Then there's a graph for the graph for Boyle's law. So the graph for a Boyle's law, if we sketch a graph, if I take pressure on y-axis and volume, it can be centimeter cube, meter cube. SI unit is meter cube. So I'm taking an SI unit. So what will be the shape of the graph? Whenever two quantities are inversely proportional, it will always be a curve. And you can see here as the pressure, if I use a number so you can understand with the numbers. So you can see here, when the pressure was 50, so when the pressure was 50 at this point, the volume was 1. It should be a straight line. So I will just change the position of this 1. So example, this is 1. And what happened as we decrease the pressure, you can see we decrease the pressure, we made it 10. And what is the volume? The volume is equals to 5. So if we increase the pressure, the volume will decrease. That's a simple Boyle's law. And how we can identify whether they're inversely proportional or how we can show. So again, the same thing. You can take any 2 points. The product should be constant. So it shows that it is inversely proportional. Like example, I took this point A. At point A, what is the pressure? 50. And what is the volume? 1. So if I multiply pressure with volume, so pressure is 50 and the volume is 1, 50 multiplied by 1, what I will get? I will get 50, the product. So I'm getting a constant answer. Same thing, if I take another point, anywhere I can take, just I'm taking a simple points to explain the idea. So I took a point B. At point B, the pressure is 10 and the volume is 5. So pressure is 10 and the volume is 5, but when I multiply them, what I will get? I will also get same answer, which is 50. So this graph also shows that two quantities are inversely proportional. So I can take any point, I will get the same result. So example, I took 25 here. I took another point C where the pressure was 25. So when I find the volume, the volume will be 2. So you can see 25 multiplied by 2, what I will get? I will again get 50. So when two quantities are inversely proportional, the product at any point I take for the two quantities, I will always get the same result. Is it clear? Any doubt in this? Take the screenshot of this part as well. When two quantities are inversely proportional, so their product is always constant. Now, we can also work out a formula for a Boyle's law. Keep in mind, this is only valid for gases, because these all laws are for gases, or also known as gas laws. Example, we have same type of a gas, same number of the particles, and at a constant temperature. So which container you think will have high pressure, A or B? We have same type of a gas, same number, and at a same temperature. Like example, this is at 25 degrees centigrade. The other one is also 25 degrees centigrade. So B is at high pressure because of small volume. Example, if I say the pressure of A is P1 and volume of A, container A here means container A, is V1. So if pressure is P1, volume is V1, so I can say when I multiply pressure with volume, I will get a constant number. I can say this constant number is K. Any constant number, I'm just representing with K. Same thing, if I have same gas, same number of the particles at a constant temperature, so when I say pressure of B is P2 and volume of B is V2. So pressure and volume, so when I multiply them, because they are inversely proportional, so pressure multiplied by volume, I will also get the same answer. The answer here, the first container, answer for the product of first container will be same as answer for the product of pressure and volume for the second container. So what I can say, I can simply say that P1 V1 equals to P2 V2. So this is called a Boyle's law equation, means the product of first pressure multiplied by first volume is equals to second pressure multiplied by second volume for identical gas with a fixed mass at a constant temperature. So P1 is the initial pressure, the starting pressure. V1 is the initial volume of a gas. P2 is a final pressure and V2 is the final volume of the gas. So this is a very important equation. You will find every year a question related to this equation. P1 V1 equal P2 V2. P1, what is P1 here? P1 is a initial pressure, the first pressure. V1 is an initial or a starting volume. P2 is the final pressure and V2 is the final volume. So some questions related to this Boyle's law so that you can understand the concept. So here in this question, you can see a diver which is underwater. He's using a breathing apparatus at a depth where the pressure is 1.25 exponent 5. Okay. So there's a diver which is underwater and he releases an air bubble. The volume of this, a bubble of a gas breathed out by the diver has a volume of 20 cm cube. So volume here is 20 cm cube. And the pressure at this point is 1.25 into 10 power 5 Pascal. At the surface of the water, the atmospheric pressure is 1 exponent 5. So basically, the idea is that the outside pressure and inside pressure will be same. So when the bubble reaches the top, the pressure is 1 exponent 5 Pascal. What is the volume of the bubble when it reaches the surface? So we need this volume. Okay. So what you can do, 10 exponent 5 here refers to like when instead of writing numbers like it is 100,000. So 10 exponent 5 means 1.25 exponent 5 means it means it is multiplied by 100,000. So what you will do, this is the first volume, the first pressure, the second pressure and the second volume. So what we will use the formula. So we will use the formula P1 P1 V1 equals P2 V2. So first pressure is 1.25 exponent 5. The first volume, that's 20. The second pressure is 1 exponent 5. And the second volume we don't know, so that's V2. So what you will do, if this is multiplied, other side it will divide. So 20 multiplied by 1.25. So D is the right answer, which is 25. Is it clear, this concept? So it's very easy to use these formulas for Boyle's law. Just you have to recognize or identify which one you take as the initial pressure and the second one will be the final pressure. So P1 V1 equal P2 V2. Any doubt in this part?